Good morning everyone. Last time we have seen image formation by convex lens. So today's our topic is image formation by concave lens, right? Image formation. By concave. So as I have said you, the image formation by convex lens is same as image formation by concave mirror. So like that, the image formation by concave lens is same as the image formation by convex mirror. In a convex mirror, there is only two types of images formed, or you can say that the two images are formed according to the different position of an object. The same thing is occurs to the concave lens. In this lens, only two types of image for the different position of an object is formed, right? So the first one is position of an object. If we take that position at infinity, then where we get the image? For that I am just forming an image with the help of concave lens. So I have to first of all draw a concave lens. So here it is a concave lens, right? And we have to draw principal axis passes from the center. There is optical center O on the center of circle 2F1, on an another center of circle 2F2. So at here 2F1, at here 2F2. Exactly on the center, there should be F1 and F2. There should be F1 and F2. Now, where you have to put an object at infinity distance. So, the two rays should be parallel to the principal axis. As I have said, if object is at infinity, then you can't see the object. Then the two rays which are coming from that object should be parallel to the principal axis. So here it is the rays. First ray and the second. So here it is two rays which are parallel to the principal axis. Now, after reflection, what happens? It just diverges from F. This is also parallel to the principal axis. So it seems to be diverged from F also. So here is the two refracted ray, and here the image is formed. At where the image is formed? On F. So at here, position of an image. Which is on F. What is the nature? You can easily see it here. The image is just virtual, right? So it is virtual. And all the virtual images are elect, virtual and elect, right? The size of an image. Size is very diminished. It's a highly diminished. Or you can say that it is point-like image. Understand? So here it is. Position of an object. If the position is at infinity, you get an image on F, which is virtual and erect and highly diminished. Understand? So here it is our first image formation by concave lens. Now the second one. As you know, in a convex mirror, we have just put an object at infinity and from infinity to the optical distance at any place, right? So in between infinity and the pole, like that we have also taken an object at infinity and between infinity and the optical center. So here it is, concave lens. Where the object is situated, it is in between infinity and optical center. It is in between infinity and optical center. So you can put an object at any place from O to this principal axis. So I am just putting my object at here. You can put it anywhere. So here it is an object. Give a name A, B. Right? For forming an image, we need at least two rays, which should be incident from point A. So at here the first ray is parallel to the principal axis. As it is concave lens, this ray will be diverged from F. What is the second ray? It should be passes from O. So, where we get an image? We get an image at here. Between F and O. Right? Image is formed between F and O. The nature of an image is virtual. And if it is virtual, then it is elect. So virtual and elect. And the size is diminished. So you can see here, there is a two types of image formed by this mirror. The type is only one, which is virtual. But it can be a highly diminished or diminished. And it can be on F or between F and O. Right? So, for the two different position of an object, we get a two different position of an image. So, here it is, an image formation by concave lens. Now, our next topic is lens formula. The definition of length formula is relation between object distance, which is u, image distance, which is v, and focal length, which is f, is known as length formula. You have seen that definition, right, in a mirrors formula also. So you can say that the definition of length formula and the mirrors formula are same. So the formulas are also same? No. There is a little difference between both of them. At here length formula is 1 upon v minus 1 upon u, which gives you a 1 upon. In a mirrors formula there is plus, and at here it is minus. Always remember that v should become first, then u. So 1 upon u should be subtracted from 1 upon v, not from u to v, right? So v should be first. So v, 1 upon v minus 1 upon u is equal to 1 upon f. Where, as you know that the v is the image distance, u is the object distance, and f is the focal length. From this formula you can easily write formula for the focal length of lens, which is f is equal to uv by u minus v. So here it is the lens formula. Just see for 2 to 3 seconds. Now our next topic is magnification of an image. Magnification of an image for a lens. Magnification is related to the image, not to the lens or a mirror. So according to it, the definition of magnification of an image is C. Means you can take the ratio of image height to the object height, which is known as magnification. So the ratio of image height to object height is known as magnification of an image. So according to it, the image height is generally denoted by h dash and the object height is generally denoted by small h. So the ratio of image height to the object height is known as magnification of an image, which is denoted by m. So the m is equal to h dash by h, which is the same formula as mirrors. For a mirror, magnification of an image. Just the difference is the second formula, which is m is equal to v by u. In a mirror, there is m is equal to minus v by u, but for a lens it is v by u. Because in a mirror, the real image is always formed in the side of object, while in a lens, the real image is formed in the other side of the object, right? For the other side, for the lens, right? It is always in the other side of the lens from the object. So according to it, you can say that at here the magnification is v by u. So here it is the two formula of magnification for the lens. So whenever the sums related to the lens are there, you have to use these two equations and the equation for the lens formula. Understand? So you have to remember this. Just watch it for 2 to 3 seconds. So here it is our three topics. First of all, the image formation by concave lens, lens formula and the magnification of an image. Now the sums related to these formulas will be seen in the next lecture. Thank you.